Hempcrete is an insulation material made up of three components: shiv from hemp hurd, lime and water. The hemp hurd is the woody core of the hemp plant and a byproduct of the hemp industry. It is usually sourced from hemp fibre producers after the valuable hemp fibre has been stripped away from the outside of the hemp stalk. The hemp hurd is then shredded into chips called shiv. As hemp is a biogenic material, it absorbs CO2 during its lifetime. Hydrated lime is hygroscopic and can convert CO2 from the atmosphere into calcium carbonate. Hempcrete has a lower carbon footprint than other common insulation materials and therefore is a good sustainable alternative. The ingredients that make up hempcrete are not common building materials and therefore do not benefit from volume price breaks that other conventional materials can. However, even so, hempcrete is comparable in cost to other insulation materials and widely speaking will be similar in price. If there was price breaks for hempcrete, then it might be more commonly used, as architects, contractors and clients will tend to opt for a conventional building material unless there was an incentive to choose something else. Hempcrete is primarily an insulation material and its main role is to bring thermal properties to a building. However, hempcrete also possesses some structural and moisture and fire resistant properties. The mix ratio of hemp to binder results in varying densities. The density of the material alters its structural and thermal properties. A high-density hempcrete mix, also known as heavy mix hempcrete, has a better structural property than low-density hempcrete. However, the thermal properties in high-density hempcrete are not as good as that of low-density hempcrete. The mix ratio you choose will depend on the type of insulation you require for the building. Like other plant-based materials, hempcrete is able to absorb a great deal of moisture with their natural porous structure. The moisture is absorbed into the internal surface area of the plant fibres and then absorbed into the cellular structure of the plant. It is a very useful characteristic in building material as it allows moisture to be taken in by the material and stored until conditions change and it is able to be released. A study in France showed that up to 596 kilograms of water could be stored in 1 cubic meter of hempcrete. Although the U value of hempcrete is not as high as some other common insulation materials, what makes hempcrete unique among other plant fibre insulation materials such as straw, cellulose and wood fibre is its ability to maintain an integral humidity condition. This is because of the properties of the lime binder. Lime has a high pH and is antimicrobial and antifungal. The presence of lime in the material means that lime coats each piece of hemp hurd and creates a surface area that resists the development of mould, even when the temperature and moisture conditions would cause mould to form in other insulation materials. Another element that makes hempcrete more desirable than other plant fibre insulation materials is the fire-resistant properties. Hempcrete is a Class B fire reaction material and offers 2+ hours of fire resistance depending on the thickness of the hempcrete. The most common method of construction of hempcrete is mixing hempcrete on site and pouring the mixture into formwork and allowing it to set in place. A disadvantage of this method is that it requires a long drying time period of approximately 45 days. Another form is precast hempcrete panels or blocks. A disadvantage of this form is that they require glue or mortar, which creates thermal bridges between the blocks, and the glue or mortar is commonly not a bio-based material, which impedes on the environmental nature of the material. However, a sustainable material such as clay could alternatively be used as a mortar. An advantage of this method is that the hempcrete is set before it is brought on site, which makes the construction process more efficient, but more labour production is needed off-site to produce the blocks. Interlocking blocks are another form that hempcrete can be produced in. This form eliminates the need for a full mortar joint between blocks. This method can also be used in conjunction with structural material, which means that the interlocking blocks can be used as a full wall build-up. A disadvantage of this form is that the additional structural material is usually concrete, and concrete is very unsustainable. However, the amount of concrete required is reduced as the hempcrete can provide additional structural assistance. Hempcrete spray is another method that has recently been adopted in France and the UK. The spray method is said to reduce application and drying time periods, making the process more efficient. However, this is a very new form of hempcrete, and the equipment and knowledge needed for the application is not widely available yet. There are some hempcrete suppliers in Ireland, the largest of which is Hempbuilt, located in County Meath. They supply and fit precast hempcrete blocks, panels and hemp flax, which is an underfloor sheeting. They also supply interlocking hempcrete concrete blocks. These hempcrete blocks can be used in conjunction with masonry construction easily, which is most common in Irish construction. Hemp Build also do a lot of retrofitting work on old buildings to increase their thermal properties. The properties of hempcrete allow for a large range of possibilities in the construction industry. The growing interest in sustainable building materials means that new innovations of hempcrete are emerging and the range of products now being produced is increasing. As hempcrete cannot be used as a structural material, it unfortunately cannot replace unsustainable materials such as concrete, but can reduce the quantity of unsustainable materials required due to its variety of properties and forms. Straw captures and stores more CO2 than hempcrete. However, hempcrete has unique properties and a short regrowth period of only 4 to 6 months, meaning that it has a higher yield of product per area of land required than other biogenic materials such as straw. It is important to consider all the properties, uses, and effects during the entire life cycle of materials before deciding what to use. Just because two materials are both biogenic does not mean they have the same environmental effects as each other. Ultimately, all materials have an effect on the environment, so it is always important to weigh up the effects of every material, even if you are using biogenic and natural materials.